Hey guys, so this is day two. Today is Thursday the 7th for B Day, or Friday the 8th for A Day. So this is day two, second day of the semester. We're going to go over this warm up, which is going to review and kind of practice some of the stuff that we talked about last time. So first we're going to review this following information. So the types of bonding are listed here, and then the elements involved and the electron movement. So ionic bonds involve a metal and a non-metal, and electrons are transferred between atoms. So that means that one electron is taken by one atom, and that electron is lost by the other atom. So one atom steals another atom's electron. Covalent bonding involves two nonmetals, and the electrons are shared between them. And then metallic bonding is just metal ions, and the electron movement is really just a sea of delocalized electrons, which means it's a bunch of electrons all hanging out, and these electrons are free, meaning that they don't orbit an atom. They're just free, kind of like an electron soup or a sea of electrons. So that's metallic bonding. So number one says, what kind of bonding is found in sodium chloride? So NaCl. So let's pull up our periodic table. Here we go. The question asked for sodium chloride, so NaCl. So let's first find these two on the periodic table. Sodium is right here. And remember that everything, I'm going to shade it in red. Everything in red that I'm shading is a metal. Okay, so those are all the metals. And then everything down here is a metal. So these are all metals. So that tells me that sodium is a metal. All right, and then chlorine is up here. I'll do this in purple. Chlorine is right here. And so that tells me everything up here is a nonmetal, including hydrogen. So hydrogen and all these elements over here are nonmetals. And so I know that chlorine is a nonmetal. All right, so I have a metal and a nonmetal. So what kind of bond do we have between them? Let's go back. I have a metal and a nonmetal. Well, it says right here, metal and a nonmetal. So that is an ionic bond. So we would expect to have ionic bonding between those two atoms. That means that sodium is going to lose his electron, chlorine is going to grab it, and then we're going to form two ions. The sodium will be a +1 ion, which we call a cation. And then chlorine will be a negative ion, which we call an anion. All right, number two, what kind of bonding is found in water, H2O? All right, let's go back to our periodic table. All right, let's find hydrogen and oxygen. Remember, let's highlight this again in purple. Everything in purple is going to be a nonmetal. So notice that both of those elements are nonmetal. So H2O, and it doesn't matter how many of the atoms you have. So in the water molecule, you have two hydrogens, but it doesn't matter. You just have hydrogen and oxygen. Since they're both nonmetals, we can figure out what kind of bond it would have. So let's go back to our chart and see what that would be. They're both nonmetals. So if we look here, two nonmetals, what do you know? It's a covalent bond. So this first one was ionic. Second one is covalent. And this is where the electrons are going to be shared between the hydrogen and the oxygen. All right, what kind of bonding is found in pure copper? Well, if ionic requires a metal and a nonmetal, and covalent requires two nonmetals, what kind of bonding is found in pure copper? So there's only one atom, and it's a metal. So that's a metallic bond. It's the only thing that's possible. So metallic. This is ionic. This is covalent. Okay, number four. When a bond is formed, it involves valence electrons. How do the valence electrons form an ionic bond between lithium and sulfur? So the fact that they're telling us lithium and sulfur really doesn't matter. And I think this question is a little confusing. But it says it's an ionic bond. And so what's going on through the electrons with the ionic bond? It says it right here. Electrons are transferred. So we're going to write transferred. All right, electrons are transferred between lithium. So that means that the lithium is hanging out with the sulfur. The lithium is going to give the sulfur one of his electrons. Lithium is going to form a +1, and actually sulfur is going to form a -2. Okay, and actually you would have to have 2 lithium ions to balance the charge. We'll talk about that. So you would have Lis2 is lithium sulfide. So that's the compound that would form Lis2. Okay, so there's our warm-up. Let's keep moving. Number 5, which of the following compounds are ionic compounds? All right, so we need a metal and a non-metal. So if we look at our periodic table, and then I can pull this up so that we can see, actually let's do a new thing. Let's do these guys here. Okay, so I got this here. And let's go back to our periodic table. All right, so let's find out what kind of elements these are. So here's our elements here. So we've got, I don't know if that's going to stay on there. Looks like it works. All right, so CO2. Remember that these are our metals. I'm going to put in black. Here's all our metals. Those are metals, and then everything else is a non-metal, except for these. These are metals too. So there's our metals in black. Let's look at CO2. I'm going to do this in red. So carbon is right there. Oxygen is right there. Those are both nonmetals. So that's 2 nonmetals. Again, the question is asking us to find which one of these compounds would be an ionic bond or an ionic compound. CO2 has 2 nonmetals, so that's covalent. So that is not our answer. All right, pure silver. Again, if it's only one element and that element is a metal, the only bond that's possible is metallic. So that's a metallic bond, not ionic. Let's look at iron nitride. So iron is down here. It's actually covered up. Iron is Fe and it's right there. And so that's a metal. And then look at nitrogen. Nitrogen's right here. Everybody see nitrogen right there? I just shaded it. That's a non-metal. So iron is a metal. Nitrogen is a non-metal. So we have a metal and a non-metal. That makes it ionic. And then we have water. And we just did water a couple seconds ago. Water was covalent, so that's not it. So we can cancel out that one, and that one. So our answer is Fen. All right, so let's write that answer in on our thing. And I hope that is making sense. If not, let me know in the chat. So that's ionic. And the reason it's ionic is because iron is a metal and nitrogen is a nonmetal. And if we're going to form an ionic bond, we need a metal and a nonmetal. We need somebody to play positive. We need somebody to play negative. Okay. All right, there's our warm-up. And then I've got an activity that we're going to do. And it looks like this, but we're going to do it together. Okay, so I'm not going to do it in this video. So if you're in class, you'll get to see us match these. So it's kind of fun. And I'm going to have you guys just tell me where you think they should go based on what we just talked about. So this is all review from day 1. Let's start with day 2. So day 2, we're in unit 5 talking about naming compounds. Our learning objective for today is to for students to be able to determine the charge of many of the elements on the periodic table based on where they're at in the periodic table. So we've done this before, but we're going to review how do you look at the periodic table and determine what the charge of each element is. Not all of the elements, but many of them. And then students will be able to name simple ionic compounds. So we'll spend a lot of time doing the formula to the name. So if you've got the formula, what is the name of that compound? So if you pick up a bottle of something, some kind of a bottle that's chemical, and you look at the formula, what's the name of that substance? Okay. And then we'll work backwards, but just a little bit, and we'll have to focus on going backwards another day because it's a little bit more complicated. So we'll start easy. We'll start with naming. Here's our overview for Unit 5. So we talked about the charges of ions, and we're going to talk about that today. Today we'll talk about naming ionic compounds. On day 3, we'll talk about polyatomic ions. That'll be next week. and we want to be able to name compounds that have polyatomic ions. All right, and then day 4, let's see, we need another day in here to talk about transition metals. So I think day 4 we'll do transition metals, then we'll do covalent compounds, and then acids at the end. So that's unit 5, naming compounds. All right, here's the charges. So if you look at your periodic table, everything in group 1, when it becomes an ion in an ionic compound, will be a +1 charge. Everything in group 2 will be group +2. Okay, and we start the groups from left to right. So this is group 1, group 2. These do not count, okay? These charges of these elements can vary. And so it's not always just one charge. It could be many charges. And we must determine the charges of these elements by reasoning and charge balance. So we'll talk about that. For example, iron could be a +2, or it could be a +3. And so that's what I mean by the charges vary. It could be more than one charge. And so you have to determine what the charge is of that metal based on charge balance, okay? And we'll do that. If it's in group 3, it's a +3. Group 4 is usually a plus or a -4. If it's a metal, then it'll be a +4. If it's a non-metal, then it'll be a -4. Okay, and then group 5 with nitrogen, that will be a -3. Oxygen family, group 6, will be a -2. And then the halogens, group 7, will be a -1. So group 1 is +1. Group 2 is +2. Remember, we skip a few. So 1, 2, skip a few. Group 3 is a +3. Group 4 is a plus or a -4, depending on whether it's a metal or non-metal. Group 5 is -3. Group 6 is -2. And then group 7 is -1. And then the last group is 0 because they don't form ions. The noble gases do not react with anything, so no ions. And then these don't count down here either. Okay, so you can look at the periodic table and find the element and see what the charge will be when it's in an ion. Okay. All right. And I'll go through some of these real quick. This will be a +1, +2. This is going to be a plus or -4. This is going to be a -2. This is going to be a -3, +1, +2, +3, -1, -2, -1, +2, +1, +1, +1, -1, -1. Silicon's going to be a +4. I'm just looking at where they're at on the periodic table. Aluminum's a +3. Gallium's a +3, +2. Barium is a +2, right? Yeah, +2. Selenium is a -2. Antimony or Sb is a -3. Lead is it could be a +4, but it could be many charges. So that one's a little weird. Indium is going to be a +3. Sn is going to be a +4. This is going to be a +2. This is going to be a -3. This is going to be a -2. This is going to be 0, 0, 0, 0, 0. And this is going to be a -1. So there's all our charges. Whew. Okay. And all I'm doing is looking at which group they're in and seeing what the charge is. Group 1 +1, group 2 +2, so on. So that'll take some practice. Okay. Now, let's talk about how to name chemical ionic compounds. So we've got several different things that we'll do when we talk about naming. The first step here is naming binary compounds, which means that the compound just has 2 elements that come together to form an ionic compound. A metal and a non-metal are going to come together and make a compound. All right, so ionic compounds are formed by a metal and a non-metal transferring electrons. A non-metal gains an electron, and the metal loses an electron. There are 2 parts to the name. All right, the first is the metal, or the positive cation. All right, so first we just name the metal. What is the name of the metal on the periodic table? All right, so we just name the metal. The second part of the name is the non-metal, and we're going to name it. But then the last 3 letters of that non-metal we're going to change the end of the name to IDE. All right, so for example, NaCl is a formula for a compound. We want to name that compound. The name of this compound is sodium chloride. So how did I get that? Na is the symbol for sodium. So when I write the name of this compound, the first thing I'm going to do is I'm going to write sodium. So I did that. I wrote sodium right there. And then the other element is chlorine. Cl is a symbol for chlorine. Element number 17. That's on the far left of the periodic table. It's a nonmetal. And so I'm going to write chlorine, but then I'm going to change the ene, the INE, I'm going to change it to IDE. So that's going to be chloride. And so that's how I get this right there. And so that's our name. That's it. Write the name of the metal first. Metal's always first. And then write chlorine, but then change the last 3 letters to ide. So that's sodium chloride, which you guys know what that is. That goes on your French fries. Table salt. Yum, yum. All right, so that's how we do that one. So let's name these guys. So if we look at each of these guys, we'll figure out what it is. So let's look at the periodic table here. Let me grab this. I'm going to do 3 in detail here, okay? So I'll do them step by step. And then the rest of them, I'll just share the answers, okay? Let's see if I can make this smaller. There we go. Okay, so the first one is lithium and oxygen, right? So this is, if we look at the symbols there, that's Li2. So lithium is there. It says lithium right there. So I'm going to write lithium. I'm not going to change the name. I'm just going to write the name of the metal. And then my non-metal part is oxygen. Oxide, so oxygen. So I'm going to write oxide. So what I did is I took oxygen, I took the last 3 letters and changed it to ide. Ide, okay? And we usually get rid of the Y. The Y usually goes away, so oxide is what it's going to be. So lithium oxide is the name of this guy. I just figured out the name of the metal. I wrote it first. I found the name of the nonmetal, oxygen. I wrote it second, but then I changed the ending to IDE. Okay, and if you accidentally misspell these a little bit, that's okay. I can kind of tell what your answer is. Most of the time, this will be multiple choice, so you should be able to pick the answer that looks closest to this. All right, let's look at the second one. Magnesium is right here. So I'm going to write magnesium. And then I got chlorine again. So that's chloride. There's our name, magnesium chloride. So I find the name of the metal. I write it first. I find the name of the nonmetal. And then I change the end to IDE. That's it. All right, next one. KF. K is right here. It's called potassium. And I know it's weird that that represents potassium because it's a K, but remember that some of these symbols and some of these names of these elements are from Latin. And so K is a symbol for the Latin word for potassium, which I'm not sure what that word is off the top of my head. Fluorine is F, and so that's going to be fluoride. So I write the name of the nonmetal, I change the last 2 letters to ide, and that's our name, potassium fluoride. All right, so that's 3 of them where I showed you guys exactly how I found those elements on the periodic table, and then I write the name. Let's go back and do the other ones, but just do them quickly to save some time. All right, and let's see this. Here they are. So lithium oxide, magnesium chloride, potassium fluoride, rubidium iodide, cesium bromide, magnesium nitride, aluminum sulfide, beryllium selenide, calcium oxide, and strontium phosphide. Again, I'm just naming the metal. And then I write the name for the nonmetal. And then I change the last 3 letters to ide. Notice that every one of these ends in ide. And that can help you identify that it's a binary ionic compound sometimes. Okay, that's most of it, guys. How do we determine the formula from the name? So if I gave you a bottle of a chemical that said aluminum oxide, right? And I said, here's a bottle of aluminum oxide. What's its formula? We're going to determine which elements are in the formula. So just by looking at the symbols, we're going to look on the periodic table and find the names of those elements. Or I'm sorry, we're going to look at the name and we're going to get their symbols. All right, so we're going to do exactly the opposite of what we just did. Then we're going to determine the charge of each of those elements, write the elements side by side with their charges, and then we're going to add either the metal or the non-metal so that they cancel out. Okay, so the one that we're going to do here is aluminum oxide. And this is a slide with it kind of completely done. And so I put this in here so that, you know, if you're absent and you have the PowerPoint, you can just look at it and it's got everything you need. But we're going to do this one from scratch. So aluminum oxide. I just want to do one example where we are determining the formula, which is a little bit more tricky. So we're doing aluminum oxide. Okay, so if we look at that, this is aluminum and oxygen. Okay, and if I look on my periodic table, I can find those two guys. And let's do that. Here's aluminum and here's oxygen. And so that's how I got their symbols. All right, I know that it's aluminum and oxygen. I find them on there. I got their symbols. Okay, so we have aluminum and oxygen. All right, let's go back to the periodic table and determine their charges. So if we look at aluminum, he's right here. This is, remember, this is group 1 plus 1, group 2 plus 2. That'll be those guys and those guys. This is group 3, so aluminum is a plus 3. And then it goes plus or minus 4, and then it's minus 3 for these guys, minus 2 for these guys, minus 1 for these guys, and then 0. So we have aluminum, which is right here. I'm going to put it in black. There's aluminum. So aluminum is a plus 3. So if I make an ion with aluminum, it's going to be a plus 3 ion. It's going to lose 3 electrons. And then oxygen is right here. He's going to be a minus 2, right? Because I got minus 2 right there. And so that's my 2 charges. And this is the first step to determining the formula. So aluminum is a plus 3, oxygen's a minus 2. So let's write them together. Aluminum is a plus 3, oxygen is a minus 2. Now, what we need to do is to balance the charge. The positive and the negative have to be equal. So I'm going to look at it first and check and see if they're equal. They're not, because I have a plus 3 and a minus 2. They're not equal at opposite charge. I would need like plus 3 and minus 3. I would need plus 2 and minus 2, plus 1 and minus 1. And so we don't have that. So we're going to add ions until they balance out. So let's add an aluminum ion. That's going to be a plus 6. And then what I can do is add oxygen ions until I get a minus 6. And so now I have equal and opposite charge, plus 6, minus 6. And it takes some practice to kind of figure out which one or how many of each you need. But one way, kind of a shortcut to do this, is to multiply them to find the shortest, least common multiple. So 3 times 2 is 6. So if you multiply them together, you can kind of see what the total charge will be, what the total positive and negative needs to be. So we need 2 aluminum ions. So I'm going to write Al2. And we need 3 oxygen ions. So I'm going to write O3. And there is our formula, Al2O3. So that's a little tricky, and we'll practice that. This is still a pretty simple example because we just have 2 elements coming together. It's just the number of each element or ion in the compound can vary. In this case, we have 2 aluminums, 3 oxygens. Okay, let's see what else we got. I think that's about it. Our assignments for today is going to be the warm-up, the in-class activity, which will be for a grade, so make sure you're present for that, and then the Ionic Ed Puzzle video, which is this video. And then I'll be making Ionic classwork, and I'll probably give it to you guys this weekend. and then you guys will have next week to complete that. Okay. We don't necessarily have to complete the classwork today in class. I'm going to make it as soon as I can, and then I'll have you guys complete that, and I'll give you a week to complete that. All right. Thanks, guys. I hope you guys learned something.